All right. Did you?
Yes, I did.
All right. Good afternoon, ladies and gentlemen. Today, we are graphing with horizontal stretch and shrink. And I'm making you do a tiny bit more work in notes today so that tomorrow, when this gets a lot harder, that you'll be like, oh, this is so easy. So here we go. Today we have a number in front of the x. And because that's a number inside the function with x, that causes changes in the x direction. So those sine and cosine curves that we learned yesterday are either going to get stretched out like a spring, a slinky, love those things, or compressed closer together, okay? And so, trying to turn the page. Come on. Oh, there it is. Okay, you do not have to write this down. I need you to get your calculators out, though. And all right, so in your calculators, I need you to type in y1. We're going to just graph sine of x. And then in y2, we're going to do sine of 3x.
Hey, starting already?
And then I also want you to graph these using the window. So this is how we denote a change in the window. So in the x direction, we want to go from 0 to 2 pi. And in the y direction, we want to go from -1 to +1. So we're going to go to window. If you have a Casio, you're going to go to viewing window, V window. And we're going to change our x-min to be 0. And then our x maximum to be 2 pi. The x scale is not too important. I'm going to make that pi over 2. So that's what you count by. What's each tick mark? And then for my y minimum, I'm going to do -1, and the y maximum, I'm going to do 1. So changing the window, very good idea. And then once you do that, you can graph it. All right, so you see middle, high, middle, low, middle. There's our regular sine curve. All right, what do you notice?
It shrank.
It shrank. So the second graph, what did that 3 do?
Shrank it.
A horizontal shrink. Yeah, it definitely compressed it closer together. So then the question is, how many periods do we see for the original function? 1 period for the original function. So that was 1 period. And we did that, it happened between 0 and 2 pi. So that original function that had 1 cycle in the length of 2 pi. Okay. So how many periods do we see for our second function, the sine of 3x? 3, okay. So you can see middle, high, middle, low, middle. That's 1 period right to there. And then again, there's another cycle. So that's the second period. And then the third. So we had 1 cycle, then another cycle, and another cycle, which makes you think of the EKG, right? That's right. Okay. So then the question is, if we see 3 periods here, the first period, the second, and this third period, then I want to know how we can determine the period for any trig function. So how
B equals period. That's a B value.
so how big, how long is this period? It's not 2 pi. It's what? 1/3 of 2 pi. That's very, very good. Each one of these is the size 1/3 of the original 2 pi. So each one of these is 2 pi over 3, or 1/3 of 2 pi. Okay? That's right. Very good. Which is, if we want to figure out what the period is for any function, it's 2 pi divided by b. So whatever that number is in front of x, if we want to figure out the period length, then it's just 2 pi over b. Okay? So that's all well and good. So we're going to do some graphing now. I'll be asking you information like that, so this is a good formula to have. We're going to do it a slightly different way today. All right, so again, we're graphing. You do not have to write all these directions. Just graph the function very carefully. That's the key. Just do it very carefully. Every time we graph, there have to be 5 points, 5 in the horizontal direction that you are required to know. So I won't accept them if you don't label. Okay, gotta have everything labeled. We're gonna figure out the amplitude, period, and vertical shift, domain, and range of the function. And then, of course, the very important thing, you're gonna graph them on your calculator to make sure you got them right. Okay, do you have to graph every single one of them? No, but practice on 1 or 2. Okay. I'm never gonna give you any keys for this stuff because you have a calculator. All right. So the first one here, we're graphing the cosine curve. And I'm going to start with the vertical shift or midline. What is our midline? 0. Midline came from what was ever added or subtracted on the outside here. So our midline is 0. What is our amplitude? No. 1. 1. There is a 1 in front. That's the amplitude. So the amplitude is the absolute value of 1, which is 1. So that's enough information for me to graph my vertical axis here. So my midline is 0. What's my maximum value going to be? 1. What's my minimum value going to be? -1. So midline, and then we do 1 amplitude above and 1 below. All right. So this is my midline. I'm going to go ahead and draw that in. Now, they asked us to identify the period, so we can do that a couple of ways, but I'm going to use the formula. So to find the period, how do I find the period? 2 pi over b. What's our b value? Oh, 2 pi over 2. Yeah. What do we have to do with that? Keep, change, flip. Sure. I don't like dividing by a fraction, so instead I'm going to do 2 pi times 2 over pi. Multiply by the reciprocal. What cancels out there? The pi on top and pi on bottom reduce. That's handy. And that's going to give me 4. So this has a period of 4. You'll notice it's not 4 pi. It's nice. It's nice. It's just a number. Okay. Don't think it always has to have pi. It doesn't. Okay. So that's the period for this function. But because tomorrow is going to be a lot more complicated, I'm going to show you what we're going to do. It's going to help us for tomorrow. So when I graph, I like to know my starting and my ending point. And if I know the starting and the ending point on my horizontal axis, then it's going to make graphing a lot easier for me. Okay. So to do that, normally my function started at 0 and it ended at 2 pi. That was the normal cosine function. Every time that we have a bunch of garbage with x, it messes up those starting and ending values, okay? And so what we can actually do is create a really easy equation. And all I have to do is solve for x. Isolate x in the middle, and it's going to give me my adjusted starting and ending values. So I want to get x by itself. What do I need to do? Divide by pi over 2. I hate dividing by fractions. What can I do instead? Multiply by the reciprocal. So I'm going to multiply by 2 over pi. I'm going to do that everywhere. Okay. So what is 2 over pi times 0? 0. And then same thing happens here as before. The pi on top and bottom cancel, and we get 4. So my starting point is going to be at 0, and my ending point is going to be 4. This is how we're going to do it tomorrow. Today, that seemed pretty... Oh, it's just 4. Yeah, that's because there's no horizontal shift. So we're starting at 0, and we're ending at 4. Yeah. For today only. Okay, never again. Okay, so today, because we're not shifting horizontally, it's always going to start at 0 and end at whatever our period is. So that's just today. All right, so ladies and gentlemen, what is halfway between 0 and 4? 2. What is halfway between 0 and 2? 1. Okay, good. And what's halfway between 2 and 4? 3. Hey, look at that. 0, 1, 2, 3, 4. That's great. Okay, so very good. That was pretty easy. Now we can graph our cosine curve, ladies and gentlemen. What is the cosine song? High, middle, low, middle, high. Very, very good. So starting at 0, we're going to graph the maximum high value, then the midline, then the low, then the midline, and then the high again. And connected in a lovely smooth curve. And there you go. There's a great cosine curve. What is the domain? Negative infinity to positive infinity. What is the range? Good. Excellent day. Okay. Questions on the first one? That was really easy, right? Oh, good. That's what we want. All right, number 2b here. Y equals 3 sine of 1/2 x. Y equals 3 times sine of 1/2 x. What is the midline on this one? 0. Good. We are adding 0 here, so our midline is 0. What is the amplitude? 3. Absolute value of 3 equals 3. And that's enough to get me started here. So my midline is 0. What's my maximum value going to be? Positive 3. What's my minimum going to be? Negative 3. 3 above and 3 below our midline. Okay, now I want to figure out the period. How do we figure out the period? 2 pi over b, which is 1/2, which I really don't like. What should I do to figure that out? 2 pi, keep change flipped. So times 2 over 1, that gives me 4 pi for the period. But because I like to be very specific, I want to know my starting and ending point. Normally, where does our function start? 0. And it normally ends at 2 pi. But because of all these changes with x, those starting and ending values need to be adjusted, adapted. So how do I get x by itself? Multiply by 2. Multiply by the reciprocal would be the easy thing to do. Good. So then 2 times 0 is 0. Get x by itself, and 2 pi times 2, 4 pi. So my starting point is 0, and my new ending point is 4 pi. So I'm going to start at 0 and end at 4 pi. What's halfway between 0 and 4 pi? 2 pi. Between 0 and 2 pi? 1 pi. And 3 pi.
Wait, so how can we do the start and end thing if it's the same thing as the period?
As the warm up to tomorrow. So do you have to do this today? No.
But is the 0 going to change or something?
Tomorrow, yes. And so is the ending point. It's not going to match the period.
Let's go.
All right. Okay. All right. So now we get to sing our sign song. What is the sign song? Middle, high, middle, low, middle. Very good. Middle, high value, middle, low value. Back to the middle. We get a lovely sine curve every single time. All right, what's the domain? Good, and the range? -3 to 3, very good. All right, any questions on these two? No, these are pretty easy today. We got one more, and then one more. We're just going to do letter C, and then that's good enough for today. Huh. Weird. I'm not changing anything. Thanks. I'll see if I can figure it out. I don't know what's wrong. All right. We have y equals -2 cosine of 3x. Plus 4. All right. First things first, what is the midline? 4. Very good. The midline is 4. Whatever is added on the outside there is our D value midline. What is the amplitude? 2. The absolute value of A is 2. Amplitude is always positive. A can change.
Really positive.
Amplitude is always positive. All right, so that's enough to get me started on my vertical numbers here. What is my midline? 4. And now the amplitude is 2. So what does my maximum value end up being? 6. And what does my minimum end up being? 2. That's amplitude. 2 units above and 2 units below the midline. 2 units above and 2 units below. This is not centered at 0, so I'm going to use a dotted line to, because it's not actually the x-axis. Yeah, you don't. I don't have to. And then, so now, what's the period? 2 pi over 3 is the period. That's it. Kind of nice. And again, if I want to find the starting and ending point, we would normally start at 0 and end at 2 pi. But all these changes with x, which today is easy, just mess things up. So again, how do I get x by itself? Divide everything by 3. So I get 0 equals x, which equals 2 pi over 3. As my starting at 0 and ending at 2 pi over 3. All right, here's where you really need to pay attention. Okay. So, ladies and gentlemen, what is halfway between 0 and 2 pi over 3? 1 pi over 3. Okay. Some of you figured that out. Okay. But I want to tell you that there's no issue. There's a very specific way that I'm saying that. And I'm saying what is halfway between 0 and 2 pi over 3? All right, and so when I say it, I'm saying it very specifically because it actually translates exactly in math, okay? So what's halfway between 0 and 2 pi over 3? Well, what is that inside stuff there? 2 pi over 3, and then what's half of that?
2 pi over 6.
2 pi, you know what? I like that answer. I'm going to leave it as 2 pi over 6. All right, that's cool. You can leave it as 2 pi over 6. You can reduce if you want to, but I'm going to just leave it for now. Now I want to figure out what's, again, halfway between 0 and 2 pi over 6. Yeah, 2 pi over 12, or on this one, 2 pi over, this is a half times 2 pi over 6. Is that pi over 6, yeah? I reduced that one. Why do you suppose I reduced that one? Yeah, now they got the same denominator. That's kind of nice. Okay. All right, what is now halfway between 2 pi over 6 and 2 pi over 3?
3 pi over 6.
It is 3 pi over 6. What do you have to do here, though, to get there? Common denominator, yeah. So this is 2 pi over 6 plus 4 pi over 6.
Just reduce 2 pi over 6.
And so that gives you 6 pi over 6 times a half. It is pi over 2, but what is it with the denominator 6? 3 pi's over 6. Okay, so here's the thing. I am not going to require you to reduce. Okay, because, and the reason I maybe don't want you to reduce is because if all the denominators match, you'll notice a pattern every single time. 1 pi over 6, 2 pi's over 6, 3 pi's over 6, 4 pi's over 6. If you reduce, you won't notice that because this would be pi over 3 and this would be pi over 2 and that's 2 pi over 3. So it's not as easy to see, okay? But it's really nice when they all have the same denominators. It's your choice how you want to do that. This is the math that's necessary for that, so make sure you wrote down how to find those things. Okay, this graph had a negative in front. What does that negative do? It reflects it. So this is a reflection of our cosine graph. So what is the reflected cosine sign? Low, middle, high, middle, low. Okay, very good. So 0, we go low, low, low. And then middle, and then high, and then middle, and low. Low, middle, high, middle, low. All right. Very good. What is the domain of this function? What is the range? 2 to 6. Very good. Okay. Do you guys have any questions for me? Good.